All right. I hope that you guys are done, right? We can continue with that. All right. I hope that you guys are done, and then we can continue that. A very good evening again, right? We're doing trigonometry 2D grade 10s. So, right, to get straight into it, we have two triangles here, triangle PQR and QSQ. No, SQR, right? Are you able to hear me, guys?
Yes, sir.
All right. Thanks. PR is 26, which means the length here is 26. PQ is 24, 24 here. QS is 8. QS is 8, and then QR is 10. Great stuff. And we have theta there, which is PRQ. Now be very, very careful. They said PRQ, right? Now PRQ would be, so we say P R and then we say Q, okay? PR and then we say Q here. So the theta that we are referring to will be this one there, okay? So let's be very much careful in terms of that. Now, what did they say? Without using a calculator, write down the value of tan theta, tan P, right? Sorry, tan P, tan angle P. So angle P would be this one. And let's remember that, good people. So I'll just write 4.1.1 here. Let's remember that if we want tan angle P, according to SOHCAHTOA, tan is opposite over adjacent, okay? Now this will tell you that, oh, okay, therefore I should look for the opposite of P. In this triangle here, good people, the longest side, which is opposite the right angle, the longest side, which is PR, is your hypotenuse, okay? It's your hypotenuse, that one. So this means that when you're looking at P, right, this angle here, when you look at the side opposite P, right, this will be QR. Then the one adjacent to P will be PQ, okay? So it means that to get that 4.1.1 there, we shall say the opposite is QR, and then the adjacent is what? Is PQ. Therefore, this means that tan of angle P would be equal to 10 over 24. I think it can be simplified further, right? Maybe by saying 5 over 12. Okay, so that is it there. And then 4.1.2, how do we get sine SQR? Let's remember that SQR means this angle there. All right, SQR means this angle here. Now the question would be, how do we get that angle there, right? Well, to get that angle, we can simply say, okay, SQR, let's look at it again, is this one, right? And the angle is here. Let's write it then. Sine SQR. Let's remember that sine is, according to SOHCAHTOA, right? Sine will be opposite over the hypotenuse. Now, when you look at SQR, when you look at SQR, this angle here, the opposite side will be that one, which is SR, right? So you shall write SR there. And then the hypotenuse, let's remember that the hypotenuse is always the longest side, the one opposite to the 90 degrees. So it means QR would be the hypotenuse there. All right, and then that will mean that the adjacent is QS, right, in terms of SQR. Yes, so it means that sine SQR will be SR, which was the opposite to the angle, okay? SR, which is opposite to the angle. Right, sorry for that. Just wanted to kind of like emphasize that so that we always remember that, isn't it? So SR is this one. It's opposite this angle, as we are saying. So SR is 6, and then QR is the hypotenuse, which is 10. So you can simplify that to 3 over 2. No, 3 over 5. Right, I hope we got that correct. And then next we have, what do we have there? 4.1.3, right? Whereby we are looking for cos theta. Now theta is this angle here, right? Oh, sorry. Let's be careful there. Which one is theta? We just try to erase that, okay? Theta will be this angle, right? They said PQR is theta. PQR is theta. So it means that theta should be that angle there. PQR. Now, it is in which triangle? It's in triangle PQR, okay? So in that triangle there, since we are looking for cos theta, let's remember that cos is the adjacent side over the hypotenuse. Now, the adjacent to theta, right? If we check this side, is it adjacent to theta? No, it's opposite, right? What about this side? This will be the adjacent. Once you know the opposite, then the other side will be the adjacent, because we know that the longest one, the one opposite the right angle, is always the hypotenuse. Okay, so it means the adjacent is QR, and then the hypotenuse would be PR. Therefore, we can say cos theta would be equal to QR, which is 10 over PR, right? Remember, PR will be the longest side, the hypotenuse, which is 26. Then I think you can simplify that to 5 over 13 there. Then that should be your answers. Did you get them correct, good people? Okay, I hope we are winning there, right? Okay, I hope that we are winning. Let's look at the second problem, good people, right? So for number 2, we're given a sketch, right? And then triangle MNP is drawn, as you can see there, MNP, right? It's that big triangle there. And then it has a right angle at angle N. So this is the right angle. Mind you, that right angle is for the smaller triangle, and also it is for the bigger triangle. So we usually call that type of an angle a common angle, right? Okay, and then MN is 15 units. A is the midpoint. As you can see, they tell you that apparently A is the midpoint. There is A there, right? Is the midpoint of PN, which tells you that PA will be equal to AN. Now they say calculate the value of AN, this one, right? They want AN. Now to get that greatens, you have to understand the type of triangle you are working with, which triangle you are working with, right? You're working with a right angle triangle AMN, right? You must choose that one because that is where AN is. So you then say, okay, in that triangle, I'm going to do this, right? To solve problems in 2D, you always have to work with two things. The given, and then the one that you are looking for, meaning the one that you want. All right. So what am I saying? Number one, you must first look at the information given. You are given an angle here, which is 21 degrees, right? And then you are given a side, which is MN. You are given MN. Now you're going to say, what is the relationship between what I'm given, right? The side, specifically, you're going to say, what is the relationship between the side I'm given and the angle? And the angle, either the angle I'm given or the angle I'm looking for. In this case, we're given 21 degrees, right? What is its relationship with the given side? Is it opposite or adjacent? Anyone who can tell us? Yes, Intando. What's happening there?
So for which one, sir? I didn't get your question, sir.
My question is, you see this side given MN, right?
Yes, sir.
Yeah, and the angle given 21 degrees, this angle.
Yes, sir.
Yeah, is the side adjacent to the angle, or is the side opposite to the angle?
It's adjacent to the angle.
Right, it's adjacent to the angle. So that's what you write. You say, oh, it's adjacent to the angle. Now you write your soccer tour, eh? Shall write your soccer tour, and then say, okay, we have an adjacent. We're going to tick where we see adjacent. Okay, we're going to tick where we see adjacent, and then from there, right? From there, after we have ticked the adjacent side, we then say, okay, let's go to the one that we want. We are done with this one. Let's go to the one that we want. The one that we want is AN, right? Which is this one here, AN. Now you ask yourself again, what is the relationship between the angle that is given and the side that you want? What is the relationship? Anyone who can tell us? I see Ngube there. Is it Ngube? Or is it Tan? Is it what? Tandi? Good people, when you look at the angle, when you look at the side, what is the relationship there? Adjacent or opposite? Or is it the hypotenuse? Yes, yes, Ntando.
Sir, the relationship, it's the angle is opposite to the given side. AN. It's opposite.
The angle is opposite to that side we want, ne?
Yes.
So we are going to tick opposite. Now, the ratio with most ticks is the one that you're going to use. Okay? So therefore, in that case, you're going to use tan. So 3.1.1, you shall say tan 21 degrees is equal to AN over remember tan again is opposite over adjacent. Yeah, the opposite is AN, the adjacent is MN. Now, right, tan 21 degrees. Now AN is not given, however MN is given as 15. Then from here, good people, you cross multiply. You write this as over 1, then you say 1 times AN is going to be 1 times AN is going to be AN, right? And then 15 times that will be 15 times 21 degrees. Then you put that in your calculator. How much do you get? Yes, sir.
Sir, you will get 5.76.
5.76. Perfect. You get 5.76. Right. Usually you can write units since they are not given, and then you have your sign. Perfect. That's how you calculate that one. So now that you got your AN, it's usually advised to actually then write it to say, oh, I got my AN as what? As 5.76. And if AN is 5.76, remember that you are given that it's equal to PA. So that should automatically tell you that PA is also 5.76. And because of that, that means you already have the size of PN now. What would be PN? Because PN, remember, is the whole length there, right? PN is the whole length there. That would mean 5.76 multiplied by 2, isn't it, to get your PN? Or 5.76 plus 5.76, right? So when you do that and say 5.76 plus 5.76, you must get 11.52. That will be PN. It's always important to write the information as you are calculating. Now 3.1.2 then says calculate PMN, right? PMN is which angle? So that will be the whole angle there, right? PMN is the whole angle there, right? is that whole angle there. It's in which triangle? It's always important to identify which triangle is it in. It's in triangle PMN, right? Usually the words themselves, they already give you the triangle you are working on. Okay, if they give you the angle in terms of that, it already tells you that the triangle you are working on is PMN. All right, so now how do we calculate that angle? Well, you're simply going to say, simply going to use the relationship between the given and what you want. How do you do that? Remember, you're going to look for angle PMN. You say, okay, do I have any given sides? You are given PN because you know it's 11,52. Then you're also given MN because it's 15 there, right? So you then say, okay, PN that is given, what is the relationship between PN and that angle that I want? You can see that PN is the opposite side, right? So if you have your little soccer tower here, you shall say, oh, okay, I'm given an opposite side. MN is what? It's adjacent, right? You tick adjacent. The one with two ticks is the one you use. So you shall say tan of PMN will be the opposite, which is PN, over the adjacent, which is MN. Right. Then you say tan of PMN is equal to, now your PN is 11,52, your MN is 15. Perfect. And then now, how do we get PMN, right? So to get PMN, remember, you need to take this tan to the other side. When you take the tan to the other side, good people, it's going to change, right? You're going to leave PMN alone. That tan, when it goes to the other side, it's going to be inverse tan, okay, of whatever it finds at that other side, at the right hand side. So in that case, you'll be able to find your PMN. You put that in your calculator, you say shift, and then you press tan, and then you say 11,52 divided by 15. You close your bracket, and then you will get 37,52 degrees, because it's an angle, right? You put degrees there. All right, if you do have any question, please do ask. I hope that we are all still together. And then let's look at this one, right? We have a cable, Cape Town car cable, right? It takes tourists on to the top of the mountain. So it starts here, it goes to the top of the mountain, which is here, right? This is the car there. So what are they saying there? The cable is 1,2 kilometers, as you can see, and then it makes an angle of 40 degrees with the ground. Okay, this is an angle of 40 degrees with the ground. Calculate the height of the mountain. So a nice question there, right? How do we solve that question there? Remember, your given side is your given angle is this one, or the angle you are working with. Right, remember, you always work with given and want. So you shall say, what is the relationship between the angle, right? What is the relationship between the angle and the given side? Then you can see that that relationship is opposite. Like, it's not opposite. Remember, that relationship there is the hypotenuse side. Remember, it's opposite the 90 degrees, ne? So it is the what? The hypotenuse side. So in terms of the given one, we are given a hypotenuse, so you write it. And then the one that you want is this one. What is the relationship between the angle and the one you want? It's opposite. It's opposite. Then the ratio that talks about hypotenuse and opposite, good people, that can only be what? That can only be sine. So we shall say sine 40 degrees is equal to the opposite side, which is h, over the hypotenuse side, which is 1,2 kilometers. All right, 1,2 kilometers. And then from there you can solve for h by writing this as over 1 and cross multiplying. 1 times h will be h, and then you'll have 1,2 sine 40 degrees. And then when you put that in your calculator to say 1,2 sine 40 degrees, you shall get here, okay. Yeah, you shall get 0.77 kilometers. So that will be the height of the mountain there. Right, I hope that is clear. Then the last question that I had for you guys would be this one, right? But it talks about something quite interesting. Now, before I can even show you, right, let's maybe talk a bit about what you call the angle of elevation and then the angle of depression, ne? Angle of depression, elevation and depression. So let me write this properly to say elevation. Right, now what is an angle of elevation? What is the angle of depression? I like to use this example here to say, let's look at a tree, right? Imagine there is a tree, imagine there is a bed, right? Oh, sorry. Yeah, imagine that there is a bed here, right? And then there is our bed there. Now, if you are here, right? If you are here, this lady who is here, right? When she's looking at the bed, she looks up, right? She's looking up, right? For her to, in fact, this lady, she's too tall. Sorry, let me make her a bit shorter. Okay, here's the ground, and then let's make her a bit shorter. Right, like this. Right, like this. Now, when she's looking at the bed, she's going to look up, isn't it? She's going to look up at the bed like this. Right, the normal side, right? When she's looking normally, when she's facing normally, the normal eyesight level will be this one. It will be straight. Okay? The normal eyesight level would be straight like this. So the blue line represents the normal sight level. She's looking straight. However, when she has to look at the bed, she looks up. When she looks up, she forms a bit of an angle here because she looks up, right? And then she can see the bed. So she forms a bit of an angle here. Now that angle, because she looked up, we call that angle, we'll call this angle here the angle of elevation. Okay, we'll call it the angle of elevation because she tilts her head upwards so that she can see. Right, and then, but when you look at the bed itself, right, the bed, who's that now? Sorry. Yeah, the bed is looking, the bed's normal eyesight level will be this one, whereby the bed will be looking straight, right? So this is the normal sight level for the bed, looking at the bed. But the bed had to tilt its head downwards so that so that the bed could see the girl, right? So it means that the bed had to tilt the head downwards and formed a bit of an angle here, right? I'll call it beta, that one. Now, because this one, the bed had to look downwards, this one we call it the what? This one we call it the angle of depression. Okay? You can think of you when you are depressed, you look down, so you form an angle downwards. So that is the angle of depression. Now you must know that those angles, good people, they are always equal, right? Theta will be equal. Why? Because they are actually alternating angles. Alright? They're actually alternating angles there. So theta and that, because the normal sight levels are parallel to each other. So that is the angle of elevation and the angle of depression. I hope that is clear, good people, right? Now, how is it applied? Let's look at a bit of a problem here from one of the November papers, and you can see by the marks that things get a bit challenging and a bit interesting, right? In the diagram here we have B, which is the foot of a multi-story building, 3 people, D, E and C, which means this is a person here, another one here at E, right? This is E, good people, and then C there, 3 people. They are standing on the windows on 3 different floors, right? These people are on the different floors. This is the building, and then the person at D is on a floor, maybe floor 1, and then E is at floor 2, C is at floor 3, right? Right. And then D, remember that will be the ground level, right? Meaning he is at the ground. Now, they are all looking at an object A on the ground. Look at object A, it's on the ground. Let's remember, good people, right, that let's look at a person which is maybe D here. This person, actually, let me just try to draw their face, right? In fact, I'll just draw the eye. Normally, D should be looking straight. This is the normal eyesight. This is the normal eyesight. But they had to look down. They had to tilt their head downwards so that they can see A, right? So it means they formed an angle of what? An angle of depression here. Even E, the normal eyesight level is that side. But the person had to tilt the head down. So it means they formed another angle of depression. I'll just call it theta, so that they could see A on the ground, right? And then C there, the same thing, good people, to say the normal eyesight level for C is like this, but they had to tilt downwards so that they could see what? They could see A. So these are all the angles of depression, right? Perfect. Now let's understand the following, right? Whenever you have an angle of depression, you're going to have an angle of elevation. Why am I saying that? This is because when you look at the person at A, the object at A, if the object was to look at this person D, the object would have to tilt their head up so that they could see D, isn't it? The normal eyesight level will be this one, but they will have to tilt up so that they could see D there. So it means they will form an angle of depression, elevation, isn't it? And it will be equal, let's remember that it will be equal to the angle of depression of D, of D. Same thing here. This one is the angle of depression. Where will be the angle of elevation? The angle of elevation will be here. So this will be equal to theta there, right? So that they could see E. This one is the angle of depression. Where will be the angle of elevation? It will be that big angle there. So we can call it alpha because it will be equal to this one. Okay? So that is how the angle of elevation and depression works, right? Now they tell you that AC is 9 units, AC is 9 units, BC is 5 units, as you can see there, right? Angle A1, A2 and A3 are equal. Wow, very nice. So A1 is equal to A2, it's equal to A3. Now if I can maybe remove those many things there, right? So if I can remove, maybe, let's see. So let's understand the following, right? Since these angles are equal, it means this angle here is equal to this one, and it's also equal to this one, right? So let's remember that this angle A1 is equal to angle B, because at D, the angle of depression is this one. It will mean the angle of elevation is this one. And since this is beta here, it means that this one is also beta, and then this one is also beta there. Are we clear? Make those betas clear there. Beta, beta, and then angle beta there. Okay. However, let's understand that since this is the angle of depression here, the angle of elevation will be this one, which means this is theta. It means theta is beta plus beta. Ne? And then this one, let me use a different color. What can we use? Orange. So let's understand that this is the angle of elevation, of depression here. It will mean that the angle of elevation is here, right? So this will be alpha, which means alpha is beta plus beta plus beta, right? Good stuff, right? That is how we analyze. But I hope I didn't make the diagram so much complicated, right? They want the size of angle CAB. Now CAB will be CAB, which means it's the whole angle here, theta, right? They want the angle CAB. Now CAB is in the larger triangle, right? It's in this large triangle here. This one, it's alpha. CAB is alpha there. So now we know that there is a 90 degrees here, right? It's a right angle triangle. We can still do what we're doing to say, to get size CAB, we shall say the given side, what is the relationship between the given side and alpha? They are opposite to one another, right? And then you also have a given side here, which is the hypotenuse. Let's remember that this one will be the hypotenuse, right? So you are given an opposite and a hypotenuse, right? Which means we're using sine. So we shall say for 4.2.1 sine CAB, right? Sine CAB will be equal to CB or BC, the longer one, right? BC over the hypotenuse, which is AC, right? So which means that sine CAB will be 5 over AC, which is 9. Then therefore, remember, you need CAB alone. You leave CAB alone there, and then you take the sine to the other side. It will become sine inverse, again, of whatever is there. Then you put that in your calculator, good people. What do you get? Shift sine 5 over 9, you get 33. You get 33.75 degrees, right? You get 33.75. It means alpha is 33.75 degrees. However, let's remember that this angle, this one and that one are equal, which means if I want to get each individual angle, I can just say the 33.75 degrees, I divide it by 3, I will get the size of each angle. Why will that help me, right? Let me show you why that thing will help us, right? Let me clean it. I know I've made a mess, I'm very sorry. Right, let's try to look at it again, right? To say, okay, sharp. Right, so now we know that this whole angle is how much? The whole angle is 33.75 degrees. Then they ask you, can you give us the length of AE for 4.2.2? They want the length of what? A, this is A, and then AE. If they want the length of AE, good people, we need to recognize that AE is in which triangle? AE is in the right angle triangle AEB. Ne? Right angle triangle AEB. And in that triangle, good people, we do not have the size of EB, we don't have the size of AB, we don't have anything. We only know that AE, we even do not know the size of AE, right? We don't know any size there, right? If I can even remove this. On that triangle, we don't know nothing, good people. Nothing. So how do we solve such a problem whereby we don't know even anything? Ne? Quite an interesting question, right? Quite an interesting one. However, good people, let's understand this. We will need at least two sides. You know, in any question that you're going to work with, ne? Always strive to have at least one angle and at least one side. Once you have this, you are okay. If you don't have one angle and one side, at least have two sides on that triangle. All the problems you're going to work with, it's either you have one angle and one side or two sides. Let me show you here. You see here we had one angle and then we had one side, isn't it? I think there's a question. Yes, Ntando.
Sir, I just wanted to ask, sir, in a test, will there be a chance where they'll give you maybe one angle and then you should try and calculate the sides?
No, you can't have one angle only, say. You cannot have one angle only. It's only one angle and one side, or you are given two sides. You get me? Look at the first problem. You had two sides, isn't it? You had AC and then, oh, sorry. You had AC and then you had BC. Those were two sides, right?
Yes, sir.
Perfect. Look at this one. You had one side and one angle, isn't it?
Yes, sir.
Look at this one. Look at AN. When you wanted AN, right? When you wanted AN, you were given an angle and a side, isn't it?
Yes, sir.
Perfect. When you wanted PMN, which was this large angle here, ne? You had one side and then you had one side, isn't it? You had two sides, isn't it?
Yes, sir.
It's always like that. And I need you to know this, good people. You must always know that if you are given two sides, then we are looking for the angle. Okay?
Yes, yes.
All the time. If you are given two sides, you are looking for the angle. If you are given one angle and one side, you are looking for the other side. Okay?
Yes, yes, sir.
That's how it always works. So in this question here, whereby now we are looking for the length of AE, which is AE, right? This large line there. The problem is that in that triangle, we don't even have an angle, number one. We don't even have a given side, nothing. Right, but let's remember that when we are looking for the other side, just like they are looking for AE, we must have at least one angle and one side, isn't it? Perfect. Now that we need one angle and one side, let's make sure that we get the angle first. We can be able to get this angle here. This one. We can get this angle. How can we get this angle, good people? Well, let's remember that I told you that they told us that A1, A2, and A3 are equal, and as we got the whole angle here, 33.75. If you divide this number by 3, right? If you divide that by 3, what would you get? Right, so let's look. Let's say you are solving for 4.2.2 here. Now, if you say 33.75 degrees, you divide it by 3, ne? What are you going to get? 33.75 divided by 3. Yes, you get 11.25, isn't it? 11.25 degrees. Which means that A1 is going to be 11.25 degrees, which means this one is going to be 11.25 degrees, and then this one is going to be 11.25 degrees, which means now we have this one. Since our main focus is to get AE and we are working in this triangle, right? It means now we have this angle. 11.25 times 2, it's 22.5, meaning here we now know that it's 22.5 degrees. Perfect. Now at least we have one angle. Now we need one last missing puzzle, one side, right? To get one side, we can at least get AB. How can we get AB? Remember that you have this side and then you have that side, and this is a right angle triangle. You can actually use the theorem of Pythagoras to get AB looking at that large triangle, isn't it? And when you use the theorem of Pythagoras there, you shall say, okay, AC squared, which is the hypotenuse, is equals to BC squared plus AB squared, isn't it? And then AC squared, which means 9 squared, BC squared, which will mean 5 squared, and then you have AB squared. Good people, you shall solve there. I think you will have 81 is equal to 25 plus AB squared, which will mean that 81 minus 25 is 56, right? AB squared. Then you square root both sides. Therefore, AB, remember when you square root both sides, AB will be equal to what? The square root of 56, which is 7,48. 7,48 units, right? Which means AB is 7,48 units. Now that we have at least a side now, ne? Now we have an angle and then we have a side. Now we can get the other side, which is AE now. So how can we get AE? We can now say, okay, the angle that we're given 22,5 and the given side, the relationship is that it is adjacent. And then the angle, and then AE is actually the hypotenuse, right? Is the hypotenuse. Therefore, the ratio with adjacent and hypotenuse is cos, good people. So we shall say cos 22,5 degrees is equal to the adjacent, which is AB, over the hypotenuse, which is AE. Which means cos 22,5 degrees will be 7,48 over what? Over AE. Right. Now to get AE, remember you cross multiply. You shall say 1 times 7,48 is 7,48. Then you have AE multiplied by cos 22,15 degrees. You divide by cos 22,15 degrees. Cos 22,15 degrees. They cancel. Therefore, your AE will be what? Your AE will be 7,48 divided by cos 22,5. You shall get it as 8,10 units. AE will be 8,10 units there. Therefore, you have answered the question. You get your full 5 marks. All right. Is it clear? Any question from there? All right. So if there are no questions, good people, that is how we solve that. Yes.